So we're going to work on Unit 1. So, any ideas? How do I simplify number 1?
Divide 3 and 15.
Close.
Dang it.
But no.
Separate them.
Separate them, exactly. So separate into 2 fractions. Okay, so the 3 belongs, excuse me? I know, thank you for sure.
You just did that. You should have quit.
Okay, so separate these into 2 fractions and then reduce. So what does 24 over 3 reduce to be? 24 over 3 reduces to be 8, right? So that's attached to an x, so just 8x plus 15 over 3 is 5. That's your answer. 8x plus 5. That's all I'm looking for. Okay? So we're starting out, slowly. We're going to ease you back into the math. Okay? Next one, solve and graph. Okay, solve and graph. 7 times 2x plus 5 minus 6 times x plus 8 is greater than 7. Okay, whether or not you remember it, Unit 1, we combine it with Unit 2, but Unit 1 had a lot to do with absolute values and inequalities. Those are greater thans and less thans. Okay, so first thing you have to do, yes, is distribute. So we distribute the 7, and we're also going to distribute the negative 6. Okay, you have to distribute both the negative and the 6. That's where people will make a mistake here. So that would give you 14x plus 35. Distribute negative 6, so negative 6x minus 48 is greater than 7. Okay, then any ideas where do we go from here? Combine like terms, exactly. Okay, so combine your x's, combine your numbers. Remember, when you're combining like terms, you're only combining on one side of the equation at a time. So the 7 is not coming in yet. So 8x minus 6x gives you, 14x minus 6x gives you 8x. 35 minus 48 is minus 13 is greater than 7. Now I can move the 13 over, so add 13 to both sides. Do you guys remember, how do you know if you have to change this inequality? When do we change it? When do we flip it? If you multiply or divide by a negative, right? Here we're just adding, so that does not change anything, so you don't have to change that. Okay, then divide both sides by 8. And we're going to get x greater than, what goes into both 20 and 8? How can I reduce that?
4.
4 goes into both, so greater than 5 over 2. Now, I do not want you to change these to mixed numbers, okay? Leave them as improper fractions if they are reduced, okay? And then when you graph this, remember I just want a 0 reference point, so just 0 in the middle, and then decide, is 5 over 2 going to be on the left side or the right side?
Right.
The right side of 0 because it's positive. Now, the trickiest part for a lot of people here is the graphing, okay, which seems a little silly sometimes, okay? The largest part that people mess up on is if it's an open or a closed circle, okay? Should this be an open or a closed circle?
Open.
An open circle, okay, so it doesn't have the equal to underneath it, and this is going to the right, okay? If you remember this inequality, that alligator matches up with the end of the arrow, okay? That's kind of how you can remember that. That's it. Okay, that's all we had to do. It was just solve and then graph. Okay, try another one. For number 3, the absolute value of 2x plus 4, okay, absolute value 2x plus 4 is equal to 16. Absolute value 2x plus 4 equal to 16. Okay, does anyone remember what do we do when we have an absolute value equation equal to? We have to drop it out of the absolute value bars, but what do you have to do? Make 2 equations, exactly. Okay, the first equation is everything exactly the same inside the bars equals the positive number. The second equation is everything exactly the same in the bars, do not change it, but we put in a negative. Okay, so the only difference here is just that negative. Then we just solve, just like a regular equation. Okay, so start by subtracting 4 from both sides. Subtract 4, we get 2x equals 12. Divide by 2, x equals 6. That's one of your answers. Okay, one of our answers is x equals 6. Same thing here, subtract 4 from both sides. Leaves us with 2x equals negative 20. We divide by 2, x is negative 10. Okay, so two different answers. Technically, this one should also be graphed. When you graph those, really you're just graphing them as points. Okay, so at 1 point at positive 6, 1 point at negative 10. Okay, so you're just graphing them as points. That's not a real big deal when you're graphing. Yes, Amy.
How do we know we have to go
There's
back
no
and check
arrows
them?
because it's an equal.
Okay, you have to go back and check things if you had, if you're solving and you have anything with x squareds in them. Okay, these ones are good. Do you guys remember what the exception is? The only time you cannot do this? When would an equation be equal to no solution?
If it's a negative.
If you have something inside the bars, so if you have stuff inside the bars, equal to a negative number. Okay, if your initial equation, your first equation, the problem I give you is equal to a negative number, that gives you a no solution as the answer. Okay, once you drop the bars, it's perfectly fine to be equal to a negative. That's fine. But if your initial equation, what the problem I give you is equal to a negative, your actual answer is no solution. Okay, I'm 95% sure that we're not going to give you those kind of like tricky if special occasion questions on your final, but technically it is possible, yes.
Is your mom writing the final?
My mom wrote the final, a while ago. Yeah.
So you know what's on it?
Yeah, I know exactly what's on it, which is why I gave you that extra credit winter break review that may or may not be the exact, very close to the final.
Can we get it still?
If you want the extra credit for it, you have to turn it in today. If you just want to do practice, then yes, it will still be on my website.
What about half?
No. You have 2 weeks, so no. But thanks for asking. Okay, number 4. 2 absolute value x plus 4 plus 1 is greater than 11. Does anyone remember how is that 2 attached to the absolute value bars? By add, subtract, multiply, or divide? By multiplication. Okay, technically there's not a multiply dot there because we don't need one, but it is technically attached by multiplication. Okay, so what would be the first step?
Subtract 1.
Get rid of the
Subtract the 1, right? Wow, so I'm impressed that you guys remember how to do this, okay? So 2 absolute value x plus 4 is greater than 10.
2.
Then divide by the 2, right? So divide away the 2. That's going to give you absolute value x plus 4 is greater than 5. Now, do we remember what happens when you have a greater than? Is this going to become a sandwich problem or does it split into 2?
Split.
Splits into 2. Remember, a less than equation, less than sounds like lettuce. Lettuce goes in a sandwich. Okay, that's kind of the only way that I could come up with to help you guys remember that. So this one splits into 2. The first equation is just drop the bars, rewrite it exactly the same. The second one, drop the bars, rewrite what was inside the bars exactly the same, but flip the inequality, so flip the alligator, change it to a less than, and it becomes negative. So flip and change. Okay, for this first equation, we're just going to solve just like normal, so subtract 4 from both sides. Gives you an answer of x is greater than 1. Second equation, do the same thing, subtract 4 from both sides. And that'll give you an answer of x is less than negative 9. Now, if you graph this, would you expect that this is going to look like a sandwich graph or heading in opposite directions? Opposite directions, exactly. Okay, so opposite directions. Are these going to be open or closed circles?
Open.
Open circles, right. And these are going opposite directions. Okay, so just like that when you graph. Any questions so far? Hopefully Unit 1 should be fairly easy, similar, remember-ish. Okay, number 5, this is the last one. Absolute value 2x plus 1 is less than 13. Absolute value of 2x plus 1 is less than 13. What did we say about less than equations? Do they become sandwiches or do I split them into 2?
Sandwich.
Sandwich, right. So you sandwich anything that was inside, do not change it, in between 2 less thans, positive number on the right, negative number on the left, always. Okay, then we're actually going to work this at the same time. So move the 1 And technically we have kind of like three sides of our equation here that we're doing all at the same time. So that's negative 14 is less than 2x less than 12. Then to get rid of that 2, you divide the 2 away. Divide everything by 2. We get negative 7 is less than x less than 6. That's our actual answer. And when you graph that, remember I always want that reference point of 0, so that just goes in the middle. Positive 6 is on the right. Negative 7 is on the left. Are these open or closed circles?
Open.
Open circles. And just color in right in between. That's your answer. That's all we're looking for. Okay. Actual homework for this is you're going to be doing the final review worksheet, or excuse me, final review unit 1. Okay, it's in your green worksheet packet. It is on page 52 in that worksheet packet. Okay, you're doing numbers 1 through 31. Okay, I will put that up here for you guys so you can see it and get started on that. I'm also going to give you that multiple choice